So good morning, students. This is first of a series of video lectures on basic mathematics for understanding physics. So we are going to cover those topics of mathematics without which even physics also cannot be understood. And we are talking about class 11th level physics. So first topic we are going to cover today's session will be trigonometry. And then subsequently, I'm going to cover the topic of slope and graph. And then differentiation, understanding of differentiation, it is necessary to understand slope and graph. And then finally, integration to a part of calculus. And all these topics are necessary to understand physics for class 11th level. Unless we know this much of mathematics, we will find it extremely difficult to understand physics. So let's start. That's our target for what this session is, trigonometry. And we are going to cover half of the trigonometry part. Let's begin. So first thing what you're going to learn are some basic ratios in trigonometry and their definition. So this is related to right angle triangle. So let's say we have a right angle triangle and vertices of right angle triangle are ABC. And very easily you can notice this angle is 90 degree. And let's say this angle is alpha. One of the acute angle of the right angle triangle is alpha. Let's define the ratios, trigonometric ratios for this angle alpha. Basic definition. What are definitions here? So there are three basic ratios. We'll see their reciprocal later on. Sine alpha. So when we look at this angle alpha here, how we should recall visually. So when we have this angle alpha here, so when we look at the side, this is the opposite side. So if we look from this, which is the opposite side. So this is opposite side here. And this is adjacent side and this is hypotenuse. Hypotenuse, all of you, I'm sure you know this hypotenuse. You can easily identify hypotenuse in a right angle triangle. This is a little bit more tricky and let's focus on this. So whenever you're calculating ratio for angle alpha, the side which is not forming angle alpha is called opposite side. And hypotenuse and adjacent are the side which are forming this angle alpha here. Sine alpha is opposite by hypotenuse. Cos alpha is adjacent by hypotenuse. Tangent alpha can be defined either as sine alpha by cos alpha or in terms of side ratios opposite by adjacent. So these are the basic definition we should know of. And you notice here how is this angle alpha formed? Which two sides are forming this angle alpha? All alpha angles are formed by intersection of two lines. So this in this case angle alpha is formed by side AB and AC which are intersecting at A. And so adjacent side is one of the side forming this angle alpha here. Thus we should keep in mind. So I hope is clear definition of what is opposite side and what is adjacent side. And understanding these two are important to not to make a mistake while calculating ratio. We'll see it later. So let's move on from here. So this is something. So we construct a triangle and a right angle triangle, and this particular angle is alpha here. And if you measure the length of the three sides here, we can find these ratios for this particular angle alpha here. Okay, so it depends on the length of the three sides which are forming this triangle. What if we construct a triangle keeping the angle alpha same, but size of triangle is different? Will these ratios change? So let's understand here. Suppose we construct another triangle. We construct the triangle keeping the angle same. So this angle is same here, but size of triangle is not same, and hence the length of the sides are not same. So here also you can calculate sine alpha. Here also calculate sine alpha. Will it give same ratio? Or will it give different ratio? Think in your mind. Angle alpha is same. Two right angle triangle. So here also you can calculate sine alpha. Opposite by hypotenuse. BC by AB. Here also you can calculate sine alpha. B dash C dash by A dash B dash. If I construct these two triangles, measure the length of the side, calculate the ratio, will the ratio be same or different? The point what is making here, and we are going to just show that also, if we of any size of triangle we construct, if angle is same, the ratios are same. It doesn't depend on the size of the triangle. Let's understand why. What we have done here to understand this point, I shifted this triangle on the larger triangle and keeping this what is same here. So you notice angle alpha is same, hence the sides are overlapping each other. So this is a bigger triangle, a small triangle. So this B side will come here, B and BC side will come here like this. So what you notice here, so if I calculate sine alpha from this triangle, it is BC by AB. This triangle is B dash C dash divided by A dash B dash. These two ratios are same. These two ratios are same. Why is that so? Can we think of reason why these two ratios are equal? This figure is here. So in this figure, we have two triangles. One is shown in the shaded part, other is a bigger triangle. Can we apply some property which proves this particular point? So what kind of triangle are these two? These two are similar triangle. So if you apply the property of similar triangle corresponding sides have ratios are same. Using that property, we can come to the conclusion that these ratios of sine, cos, and tan alpha are independent of size of the triangle. What are the three other ratios? We have talked about three ratios, sine, cos, and tan, which are more common ones. If we take the reciprocal, there are three other ratios. Reciprocal of sine alpha is called cosec alpha. Reciprocal of cos alpha is called sec alpha. Reciprocal of tan alpha is cot alpha. So again, this ratio also, but if we talk about cosec alpha will be equal to hypotenuse by opposite side. So these are basic definition, and we should be absolutely thorough with basic definition and ratio. And any triangle, we should be able to very quickly identify which ratio we have to take for particular trigonometrical function. Let's move on. Previous slide, we have seen these ratios are independent of size of the triangle. It's also independent of orientation of the triangle. What we mean is a very simple point, but let's understand this point also. So if we change the orientation without changing the triangle itself, at present orientation, let's look at this current orientation. What is the orientation here? This is angle alpha here. So adjacent side is horizontal and opposite side is vertical. And that's orientation. What if we change the orientation? How do we change the orientation? If I rotate the triangle, its orientation will change. So let's rotate by 90 degree. So this is the clockwise direction. Let's rotate this triangle by 90 degree in clockwise sense. So this is the triangle. Let's start rotating it. If I rotate by 90, this is how it will rotate. We are rotated by 90 degree. So what has happened here? The angle alpha, which was here in the base, it has gone onto the top. And so, but still, this is the side. Still, this is the side which is forming angle alpha. So this will be adjacent side, and other one, this is the opposite side. So if I calculate sine alpha in this triangle also, still it will be BC by AB. So again, so important point what we notice here is it is independent of orientation. Whichever orientation we look at the triangle, if angles are same, the ratios will come out same. And so in our mind also, we should not get stuck with the triangle of this nature only. Sometimes in the question, the triangle which gets formed will not be like this. It may have a different orientation, and we should be able to find the ratio for any orientation. Okay. Now, one more thing, so far we had taken only one particular angle. One, I see this is out of three angles in the triangle, one angle is 90 degree. Other two angles will of course be acute angle. So previous cases we have seen how to calculate ratio for angle alpha, one particular angle of the triangle. Well, can we not calculate trigonometric ratios for other angle? Yes, we can. So that's what we are going to do in this particular slide. Ratios for two acutes in a right angle triangle. Let's do that. So there are two acute angles, alpha and beta. Both will be less than 90 degree. The sum of the three angles have to be 180, and this angle is 90. So sum of these two is 90 degree. So if we have to calculate ratio for angle alpha, let's calculate first ratio for angle alpha. For angle alpha, to calculate ratio, first we identify which is adjacent side and which is opposite side. Which side is adjacent to angle alpha here? Identify the side which is adjacent side for angle alpha. BC is adjacent side. So what are the ratios for angle alpha here? Sine of alpha will be opposite by hypotenuse, which will be AB by AC. Cos of alpha will be adjacent side by hypotenuse, which is BC by AC. And tangent of alpha will be opposite side by adjacent side, which is AB by BC. So practice this one. Those who are not very comfortable finding the ratio from a given triangle, practice few times so that you're absolutely clear and you can do it quickly without any error. So we have done this calculation for angle alpha. Can we do the same thing for beta? Can we find the sine beta, cos beta, and tan beta? Yes, we can do that. So when we calculate beta here, so when we are calculating ratio for angle beta, again, we need to identify which side is adjacent and which is opposite. So when you look at this, which is opposite, I think opposite and hypotenuse are very easy to identify. This, of course, is hypotenuse. Which is opposite to beta, this side becomes opposite to beta. Now, BC side becomes opposite side for beta. So can we calculate the ratio here? What will be sine beta? Sine beta will be opposite side by hypotenuse, which is BC by AC. Cos beta, when we calculate cos of this angle, it will be adjacent side by hypotenuse, which is AB by AC. And tangent beta will be opposite by adjacent, which will be BC by AB. So similar way, so we can, this is how we calculate here. So do we notice something here? Any kind of relationship? So what was adjacent here has become opposite here. The side adjacent and opposite interchange if we calculate the ratio for two different acute angles of a right angle triangle. What else we notice here? We notice the cos alpha value is equal to sine beta. This ratio is equal to this particular one. And similarly, we notice this ratio, sine alpha is equal to cos beta. So if you write what we notice, sine alpha is equal to cos beta. So does it mean that sine of any angle is equal to cos of any other angle? No, that is not. There's some particular relationship between alpha and beta. Can we think of how this angle alpha and beta are related? How are these two angles alpha and beta related? Can we have any mathematical relationship between angle alpha and beta? Yes. Alpha plus beta is equal to 90 degree. They are complementary angle. Sum of the three angles is equal to 180. Or since one angle is 90, sum of alpha plus beta is equal to 90. So the result is this result. Why this result has come? Because of interchanging of adjacent and opposite side. So can we generalize this result here? What is sine of alpha? This is something when we say sine of any angle is equal to cos of its complementary angle. Let me repeat. What is this? How do we generalize here? This relationship is valid only when beta is complementary to angle alpha here. So can I write this here? So I can write sine alpha is equal to cos 90 minus alpha. So beta is 90 minus alpha. So sine of angle is equal to cos of its complementary angle. Let's understand this statement with terms of few examples. Sine of 10 will be equal to cos of what angle? Sine of 10 will be equal to cos of angle complementary to 10 degree. Complementary angle for 10 degrees, 80. Similar way, sine of 30 will be equal to cos of which angle? Sine of 30 will be equal to cos of its complementary angle, which is 60 degree. And sine of 60 will be equal to cos of its complementary angle, which is 30. Similar thing, I could have written cos here. What is cos 30 equal to? So if you have to say what is cos 15 equal to? Cos of 15 will be equal to sine of which angle? What is the angle I should write here so that these two terms are equal? I'll write the complementary of 15, which will be 75. And this understanding or derivation kind of thing is clear from if you look at the triangle and calculate the ratios. And from this ratio, one more thing we can arrive at. If I calculate sine square alpha plus cos square alpha, this I'm not doing it here. It's very simple. You'll find this will come equal to 1. Because in the numerator will be AB square plus BC square, which will be equal to AC square. So, in similar way, if we calculate sine square beta plus cos square beta, again it will come equal to 1. In general, what we can write from here, sine square of any angle plus cos square of the same angle is equal to 1. These two angles have to be equal. So basically, any angle, theta can take any value. So if I say what is equal to sine square 30 plus cos square 30 equal to sine square 30 plus cos square 30 will be equal to 1. So what is necessary condition for square of angle of basically these two angles must be equal. Okay, and this can be derived, this can be easily arrived at from Pythagoras theorem, applying Pythagoras theorem to these ratios. Okay, so for any triangle, we can calculate all three ratios of two acute angles. Let's practice this point here. So here again, let's practice with the adjacent and opposite side, and let's learn how to calculate ratios quickly and correctly. So what we need to do here, we see four right angle triangles. We need to find sine, cos, and tan of two acute angles. So let's say each triangle, we need to calculate sine of alpha. We need to calculate cos of alpha. We need to calculate tangent, and similar way beta also. Sine beta, cos beta, and tan beta. That's what we need to do for starting with green triangle, then pink triangle, and then purple color, and then for blue color. Okay. So those who, if you want to gain practice, you can pause this video, find all the values, and then check where values are correct or not. And those who are very comfortable, very quickly can do and move on. Let's begin. So if you want to do, pause it and do it, and then let's check. So let's start with this triangle here. To find this ratio, I need to know all three sides. Only two sides are given. So third side can be, since it is right angle triangle, third side can be found by applying Pythagoras theorem. So what is A be equal to? A will be equal to root of 12 square plus 16 square. If I calculate, this comes equal to 20. I'm not going to calculation. So first we have found the third side. Now calculate sine of alpha. Sine of alpha is opposite side by hypotenuse. So which is 12 by 20. What is cos? Cos of alpha is adjacent to alpha, side adjacent to alpha, divided by hypotenuse. That will be 16 by 20. And what would be tangent? Tangent, I can take this divided by this, which will be 12 by 16. What will be sine beta? Do I need to, again, when I take sine beta, I need to take the opposite side by hypotenuse, which will be equal to 16 by 20. Or I could have done, what is sine beta? Sine beta will be equal to cos alpha. I could have picked up this value. So what is cos beta? Cos beta will be equal to sine of alpha, which is 12 by 20. And we take the ratio sine by cos, 16 by 12 equal to 10 beta. So this is, so once we do this one, rest all also, we can sine value is equal to cos and cos value is equal to sine. We can find all the value. We should repeat the similar exercise for this triangle also. Similar to it, you can find the size of hypotenuse, which will come equal to 25. So if you have to calculate the ratio, sine alpha will be opposite side by hypotenuse, which is 7 by 25. And what will be cos alpha? Cos alpha, this is side adjacent to cos angle alpha here, 24 by 25. And tangent will be 7 by 24. I am not calculating this thing, very easy to calculate. How about third one, purple color? This side will be equal to square root of 9 square and 12 square. So which will be equal to 15. This side is 15. What is sine of alpha? Sine of alpha will be this side divided by hypotenuse, opposite by hypotenuse, 9 by 15. And I'm not simplifying. Basically, this is only to help you practice with the process of finding these ratios quickly and correctly. And what will cos of alpha? Cos will be adjacent side, the side which is along with angle alpha, 12 by 15. And what will be tan? 9 by 12. Finally, we come to this triangle here, blue color. And this is a little different, a little more interesting. Two sides are equal here. In this particular case, all these cases here, without using protector, we cannot find the value of angle alpha and beta. What makes this triangle interesting? We can find this angle alpha and beta without use of protector. How do we find this angle or beta? See, we notice this isosceles triangle. Two sides are equal, hence these two angles also will be equal. And since the sum is equal to 90 degree, each of these two angles will be 45 degree. So here in this particular triangle, we know the value of angle alpha and beta, which is equal to 45. And if we calculate side D using Pythagoras theorem, it can be written as, root 2 into, let me rewrite that part. So what is side D? Side D also, again, like applying Pythagoras theorem, we can calculate that D will be equal to square root of 4.5 square plus 4.5 square. So this can be written as, we can take 4.5 square as common, it is same for both. and 1 plus 1. So this term can be written as 4.5 into. So whenever two sides are equal, hypotenuse is root 2 times the each side. Now let's calculate the ratio. Now we'll calculate, so not only alpha, I'll write what is sine 45 equal to. Sine of alpha or sine of 45, opposite side by hypotenuse, 4.5 divided by 4.5 root 2. So this will become equal to 1 by root 2. And cos alpha also will be equal to 1 by root 2. From this triangle, we have arrived at value of sine of 45, cos of 45, and tangent of 45. Tangent of 45, suppose tangent of alpha will be opposite by adjacent, which is 4.5 divided by 4.5 is equal to 1. So on this triangle, with the help of this triangle, we have found the ratios for angle of 45 degree. So what is needed to find these ratios? If we know two sides of the triangle and the angles, we can calculate those ratios, which we apply later. Okay, let's move on to something. In previous case, we have found the ratios for 45 degree. Can we find the ratios for 30 and 60 degree? You notice one thing, 30 and 60 are complementary angle. So if one of the angle in a right angle triangle is 30, automatically the other angle will be 60. To find the ratio, we need to construct a triangle where angles are 30 and 60. Can you think of easy way of constructing a triangle, right angle triangle, which two angles are 30 and 60? So one of the ways, what I've done here is kind of hint for you. I have constructed an equilateral triangle. EBC is an equilateral triangle, all sides are equal, hence all angles also are equal. Okay, now if I have to form an right angle triangle, from A I drop a perpendicular on side BC. If I drop a perpendicular, this will be a perpendicular bisector. I hope this you know this property of equilateral triangle. It will be perpendicular bisector. So it divides the triangle in two parts. Each triangle the right angle triangle. So we needed a right angle triangle. Now we have a, and can we identify? So if I take this left part of the triangle, left triangle, what are the two acute angles in this triangle? This angle is 30. Plus angle 60 is a angle bisector. So this is 30 degree, and how much this angle will be? This will be 60 degree. So now I have a triangle which has two angles of 30 degree and 60 degree. Do we know the length of the sides? Let's say, assume the size of the equilateral triangle was L. This side was L. Can we find this length of the side here? Side BC was L. BM is half of it. So BM will be equal to L by 2. So now we have two sides of the triangle. Can we find the third side as well? How do we find the third side? Side of the triangle AM. How do we find the side AM? It's a right angle triangle. By application of Pythagoras theorem, we can find the side also. Hypotenuse square will be equal to sum of square of two other sides. Let's put those values here. What is AB square? L square. What is BM square equal to? L by 2 is whole square plus AM square. So from here we get the value of AM square. L square minus L square by 4. It will be equal to 3L square by 4. So what would AM be equal to? Square root of this. So this will give you value of AM is equal to root 3L by 2. The third side is root 3L by 2. And this is something you should visualize this one. You should get a mental picture of what you see here. So once I have this triangle in front of me, I can easily calculate the ratios, trigonometric ratios for 30 degree as well as 60 degree. Can you do that one? So if you want, you should ideally pause this video, find these values and check. Okay. So what we are going to do here. So this is the tip. Let's see that one. So forget that one. We already know sine of 45, which I calculated in previous sheet, which was 1 by root 2. Can we find the ratio of sine 30? So can we fill up all question mark here? Sine 30. So I have to find the ratio of sine of this angle. Sine of this any particular angle is opposite side by hypotenuse. So sine of 30 will be equal to, what will sine 30 be equal to? Sine 30 will be equal to L by 2 divided by L. What is L by 2 by L? It is 1 by 2. So sine 30 is equal to 1 by 2. Similar way, can I calculate sine of 60? When I calculate sine of this ratio, I will look at this, it becomes the opposite side. It will become sine 60 will be equal to root 3L by 2 by L. So L will get cancelled. What would be left here? Root 3 by 2. That's sine 60. Sine N and sine 90 is equal to 1. So basically this is 0 and 1. We are not giving a proof, but this value sine 0 is 0 and sine 90 is equal to 1. So we have filled up all the values for sine 30, 45, 60. Can we fill up the cos values here? Can we think of a very quick way of filling the cos values? What will cos 0 be equal to when the sine values are known? Cos 0 will be equal to sine of its complementary angle. So cos 0 will be equal to sine 90, hence it will be equal to 1. Cos of 30 will be equal to sine 60, which will be equal to root 3 by 2. Cos of 45 will be equal to sine of 45, 1 by root 2. And cos of 60 will be equal to sine of 30, 1 by 2. And cos of 90 will be equal to sine of 0, which will be equal to 0. And once we have sine and cos value, tangent will be sine value divided by cos value, 0 by 1. This will be 0. This will be 1 by 2 divided by root 3 by 2, which will come equal to 1 by root 3. This value will be 1, and this value will be root 3, and this value will be 1 by 0. 1 by 0, anything in the denominator is infinity, very indeterminate value. So this is how, if we keep this triangle image in your mind, without memorization, you can find the ratios for 30 degree and 60 degree. But you should not do that. This kind of table, it should be part of your permanent memory. This figure should never forget, because this is very commonly used. This must be a part of your permanent memory. Let's move on further. One more triplet we know, Pythagoras triplet, 3, 4, 5. What is Pythagoras triplet? The square of the two terms is equal to square of the third one, largest term. 3 square plus 4 square is equal to 5 square. So if I construct a triangle of sides of 3, 4, and 5, it will always be a right angle triangle. The angle opposite to 5 or hypotenuse will be 90 degree. When I construct this triangle, it will be a right angle triangle, and two other acute angles will be 37 degree and 53 degree. If I construct the triangle using a protractor, if I measure this angle, the angle opposite to larger side will be 53, opposite to smaller side will be 37. Sum of them is 90. If I have this triangle, I can find trigonometric ratios for 37 degree as well as 53 degree. Can we find these ratios? Should be simple enough, and you should be easily able to do that. Acute angles are 37, 53. So if I have to find the ratio for 53, 3 becomes adjacent side, 4 becomes opposite side. And what are the ratios? Sine 53. Sine of 53 will be 4 by 5. Cos of 53 will be equal to 3 by 5. Tangent of 53 will be equal to 4 by 3. And a similar way I can calculate for 37 degree. Sine of 37, if this angle for which I am calculating sine, it will be opposite side divided by hypotenuse 3 by 5. Cos of 37, 4 by 5, and tangent of 37, 3 by 4. Right, so so now what are the angles for which we know the ratios? We know for 30 degree, 60 degree, 45 degree, 37 degree, and 53 degree. For all these angles, we can find all the trigonometrical ratios, sine, cos, tan, and its reciprocal, right? So that brings us to the end of first part of trigonometry. In next session, I'll continue with the second part of trigonometry. Okay, so we'll stop here. We'll continue in the next session.